Let's talk about this thing. So a little while ago, I ran into this equation. If you're familiar with logarithms, you may find it a little silly. I did too originally. But then I noticed some curious things about this type of algebraic representation. But let's break it down a little before I get too ahead of myself. A logarithm is the inverse of exponentiation. So say we have 3 to the power of 2. This results in 9. The logarithm is the result of taking the base, which is 3, to the argument, which is 9. We are asking what is the value of the power required to make 3 into 9? And of course, in this situation, it is 2. Very basic math so far. Now, in the case of our weird little equation, what we are doing is simply replacing the exponent with the logarithm, which kind of makes the whole thing redundant in a way, and it conceals the actual value of the power. This basically means we can kind of plug in almost anything we want for either x or y. And we don't have to worry about actually calculating the exponent. At first I thought it was kind of neat, but also kind of pointless. Why bother with an equation that can just be anything? But then I wondered what happens if you actually try to graph this thing on a Cartesian plane. At first, of course, I thought it will just cover the entire thing. It appears that for every value of x, we can have every and any value of y, assuming we can use negative numbers without problems. Otherwise, we are kind of constrained to the positive quadrant. But then I realized that we also can't graph values when x and y are 0, and again when x is 1, which would generate these 3 empty lines. With the base of 0, our equation becomes undefined. There's no known way of multiplying 0 by itself to generate a regular number. Also, there's no ordinary number that can be somehow multiplied by itself to generate a 0. A similar issue occurs when we have 1 as the base. Again, how can you multiply 1 by itself to generate some number other than 1? The only situation that seems to allow for this is when both the base and argument are 1, allowing us to shade this point in. However, we could use complex numbers, so maybe this line should be filled. Not too sure. Now, I'm also tempted to say that this also is a real result. When x and y are both 0, this point ought to be filled. After all, 0 to the power of anything should be 0. But to be honest, the whole thing already broke my brain, so I just straight up don't know. The whole thing is actually quite bizarre. Graphing expressions, equations, and functions is one way to get to understand them, but this one just throws me a curveball. If anyone watching this video has seen something like this before, I welcome the comments. Now, I didn't stop there. I considered a different equation that has similar properties. I'll let you take a moment and just absorb this thing. Look at how stupid it is. The y's cancel out, leaving us with the obvious reality that x equals x. Maybe this is why nobody tried to graph these things before. At least I haven't heard of anyone that has. Okay, so let's graph it. Both x and y can pretty much be anything except when y is 0. This would fill the entire plane except for this line here at the x-axis. Notice that this is a much simpler situation compared to our previous graph. Now this is where things get interesting. I decided to plug in our old friend, the parabola, right here. The result was that when this is equal to 0, our equation becomes undefined, which means that the whole Cartesian plane can be filled except for this region, which incidentally corresponds exactly to our original parabola. The two fit like a film negative, or a mold to a cast. It is almost like having an inverted graph. Now, I'm pretty confident that this can work with most basic functions. The original equation also can have a similar adjustment, giving us something like this. Now, as for application, or how far this whole thing goes, I honestly don't know. I just began exploring with this type of graphing. Well, I hope you guys enjoyed this one. In most of my videos, I'm pretty sure the math is solid, but in this case, I don't even know what I'm dealing with. Like, subscribe, check out my other stuff, and I hope you have a great day.